people interpret that as like, I can graduate from boot camp and immediately do this. And it's like, no, you need to get the commensurate experience. We just need to be more vocal about getting it through non-privilege based channels, so that people who can't get a PhD are still welcomed into those types of like roles, both in the community and in jobs, so that we can have, as I mentioned before, a very diverse and like well-rounded community.
This episode of Ken's Nearest Neighbors is powered by Z by HP, HP's high compute, workstation grade line of products and solutions. Today, I had the pleasure of interviewing Chelsea Parlett. Dr. Parlett is a full-time faculty member teaching undergraduate data science and computer science, and earned her PhD just this year in computational and data science. She also does casual statistical consulting at the Statistician, which aims to empower people to do their own statistics well. In her free time, Chelsea makes educational and just for fun statistics memes, TikToks, and art. In this episode, you learn the difference between a Bayesian and a Frequentist. You also get a picture about why people pursue PhDs and the values, the benefits, and the drawbacks associated with that. I hope you enjoyed this episode. I know I did. Chelsea, thank you so much for coming on the show today. I'm so excited to have you. We're both mutual friends with Nick Wan, and we met on his stream for the first time. We had an awesome conversation, I think, about the underrepresented berries out there. And
you had special edition blueberries.
Exactly. Limited edition blueberries.
Limited.
And after that conversation, I figured I had to have you come on my podcast. You said some really interesting stuff about your experience teaching, going from psychology to data science, and your passion for statistics and sharing that over Twitter and TikTok. So I wanted to touch on all those things, and I wanted you to come and tell your story as well.
Awesome. That's funny that you mention psychology to stats in the same breath as Nick, because he and I did similar things, but in a very different way and at different time points in our career. So it's been interesting for me to get to know him, because I think he really switched after all his eggs were in the psychology basket. And I was lucky enough to decide that I wanted to switch before getting a PhD. But it's interesting that we've ended up in similar-ish places, although we obviously have very different emphases. So it just shows there's so many paths.
I agree. Oh, and so breaking the third wall here, for everyone listening, make sure you check out my conversation with Nick on the podcast. After this, I'll make sure that I link it, and then you can compare two very interesting career paths from psychology to data science. I also actually think Eugene Yan, who I had on the podcast a couple of weeks ago, didn't have exactly that path. He didn't go down the graduate school route, but he did study psychology undergrad. And I was a psychology major as my first major in college, as my first love. But then I took a research methods and statistics course. And it's a long story. We had to do the testing on the rats, and I named mine. And then I realized that we don't get to keep the rats. And the rats, my rat sneakers went into a very dark place, unfortunately. Yeah. But lightening things up, I'd love to hear how you first got interested in statistics and data science.
Great. What a great jumping off point. So related to what you said, I think it's interesting that you said that you were like, your first love was psychology and then you took a research methods course, because that happened to me as well. But it happened to me fall semester of my senior year. So it was too late to really do anything about it, which is why my undergraduate degree is in psychology. And it wasn't because I was determined to do psychology. It's because it was too late to change my major, and I didn't want to take on student debt. So I came into college actually as a political science major, took all the law classes, decided, oh, wait, I hate everything except law classes. So once those were done, I still had to get a bunch of credits and I didn't want to anymore. So switched to psychology and just thought that was what I was going to do. wanted to go to graduate school, probably because I'm a nerd, and read that a bunch of places required, like, I guess I would call it advanced statistics. So like not your basic like SPSS t-test type of stats course, but the only one that was offered through my department was only for honors students. So I was not one, not because I wasn't honorable, but because I didn't enroll in the program, and had to go beg the professor to take the class my senior year. And he was so gracious and nice. I was so nervous to ask him for some reason. And he was incredible and is still a friend and mentor to this day. And at the time that I had him, he was working for a statistical software company after giving up a tenure track job. And so he truly had this great insight of both the academic and the industry world, and a passion for statistics I'd never seen before, because I'd had to take maybe like 3 or 4 statistics classes before this, depending on what my major was, and in high school. And I hated it. It was horrible. No one truly understood what it was used for. It felt like they were just teaching us to like pass the AP test, or because they had to get us to buy SPSS licenses or whatever. And this is the first person that I had ever met that truly loved statistics and thought it was magical, basically, was the way that I felt about it. And so I took that class, and then I was over, and I was like, oh, I'm really good at this. I really like it. And from talking to my professor, I went to his office hours every week. I never left him alone. I'm so surprised he still wants to be in contact with me. But he had told me a lot about like what one can do with statistics. So I decided to not make any sudden moves, go do a research-based job for a while and find my bearings, see if I wanted to do stats. And so I worked as a lab and data manager at a cognitive science research lab. So I basically got to use all the expertise I learned in my degree, get more research experience, and do as much statistics as I wanted. Because if you've been in the psychology world, you know that there can sometimes be this idea that like they all hate statistics. They hate doing their stats. They love theory. They love collecting their data, but they don't want to do the stats. And so anytime I would tell someone I love statistics, they were like, do my statistics for me. And so I basically did that for a couple of years and like built my skills, took a crap ton of community college and auditing courses, and applied for graduate school and decided I'm going to do statistics, because it basically seemed like that was the thing about me that was most valued and unique. Like people were going to pay me a lot of money. People were going to want me in that field because not everyone wanted to be in that field. And so I applied to a bunch of graduate programs. My husband was actually applying to graduate school at the same time, so it was a bit convoluted, but we ended up choosing to stay in Orange County, California, where we are now. And I did a computational and data science PhD. But if you've ever done a PhD, you know it's very like you choose your own path. So my particular specialization was statistics and like inferential statistics mostly, focusing on methods that help people who do the type of research that I had been doing for the past couple of years before graduate school. Anyway, now I'm here. And that's how, in a very large nutshell, I transitioned. Obviously, it was more complicated than that, but to give you the highlights.
No, I really like that. To me, it's an interesting story because you learned quite a bit about what you didn't like in college, and even throughout the whole process. And I think that that's a really important thing when you're learning or you're trying to establish a career, is you have to try things to figure out what you like. I mean, you can't just be like, oh, I've read about this field a little bit, I'm sure I'll like it. And then once you start doing it, a lot of the times you're like, oh, I don't enjoy this that much. And I see even with data science, statistics, this domain, there are a lot of people that are like, oh, I would love that. And then they go down this path and it, they study a lot and they realize that, wow, this actually wasn't for me because of XYZ reasons, because of this part of the data science pipeline. And it to me it's very interesting because I find a lot more of the stuff that we talk about and the stuff that I put out there is valuable as like reasons why not to get into this field, because you could really save someone a lot of time, a lot of effort, and potentially a lot of money if they realize by doing it that this isn't going to be for them.
Yeah, I've seen some of your videos about like, don't be a data scientist. You wouldn't expect that from a channel like yours.
Yeah, well, I mean, there are even parts of the data science pipeline that I don't enjoy, and I've really had to work my own, my own job, my own things that I study and work on to focus more on the things that I like, the model building or whatever it is, and less on the things that I don't enjoy that much. And you kind of have to get sort of deep in the career path to be able to choose as much, or you have to be really good and really specific about your job search. But even within the domain, there are things like that. And obviously, you just mentioned that you did that with your PhD in computation and data science, right? You focused on that statistics element.
Which, yeah, the field is so varied as well, because even our friend Nick has his data competition sliced, where they're essentially doing 2 hours to build a model. And watching those has been really interesting because it's so different from what I do. So I have a background in machine learning. That's what my lab in graduate school did, and like the work that I still collaborate on. We do a lot of machine learning, but my personal work is more on inferential statistics. And it's wild how different those things are, even when they use the same methods. And so it's been really interesting watching a competition like sliced and say, whoa, like I get they're doing this in 2 hours, so it probably looks different than what you would do in real life. But I was just like, whoa, like we focus on really different things, and that's within the same field. Like I can envision myself and the people competing on slice applying for similar positions, and yet we have such different ways of thinking about things. We have such different workflows that are ostensibly all part of the same field.
Let's dive into that a little bit more. I mean, you're a noted Bayesian or Bayesian, as depending on your level of supposed elitism about how you say it, compared to, I guess it's a frequentist. I'd love to understand, one, why you've chosen that path or why you find it more reliable, and also just a little bit more about what that means. I think that a lot of people, including myself, have some understanding, but would love probably some expansion there.
Okay, well, don't crown me queen of Bayes because I am not the ultimate expert. But interestingly, I got into it when I was at my job between undergrad and graduate school. So I was at UCI. I think it might be easier to just refer to it there. I had heard of Bayesian statistics before, and I actually went to my mentor when I heard about it. I was like, oh my God, have you heard about this like new field? Not knowing it's hundreds of years old. And he actually was like, oh, I don't buy it. Like, I don't think it's good or practical. I forget what he said, but he was definitely like, no. And I still tease him about that to this day because we talk and work together sometimes, and I just joke and I was like, it's funny I turned out to be a Bayesian despite your initial discouragement of that. But I learned about it in the context of hypothesis testing, because there's a group at UCI that does Bayesian approaches to cognitive science, and their kind of baby, their software is JASP, which really is well suited to the types of questions psychologists are used to asking. And so it uses a Bayesian framework, but it does hypothesis testing. And I'll touch on that in a second. But basically, in general, you think of the idea of Bayesian statistics, I would say, in 2 ways that people like to distinguish it from frequentist. The first way is that Bayesian statistics is built on this idea of continuous updating of information. So in frequentist statistics, if you're doing it right, you should be making a plan, making a hypothesis, figuring out your statistical power, your sample size, your alpha level, all of those parameters, and then collect your data, do your test, and then use all of those tools and parameters that you set beforehand as a decision-making procedure. Like that's why we have the, reject, fail to reject framework that everyone I'm sure has learned in AP statistics or in a YouTube video somewhere. It's because that framework is for decision making. It's a way to make decisions where we, with a little bit of knowledge, can try and control how often we're wrong, both in the case of false positives and false negatives. But the reason why Bayesian statistics is, in my opinion, appealing and is different is because it doesn't necessarily buy into that framework. And I should be specific because I'm sure there's going to be some frequentists out there that get mad at me. What I was just talking about is null hypothesis significance testing, the p-value, reject, fail to reject, all of that. I found Bayesian statistics exciting because it basically said, we can continually update evidence. We don't have to plan a single experiment, get the p-value exactly correct, and make a decision. We can continually say, here's more information, update what I had learned before. And with that comes this idea that we knew things before. And in frequentist statistics, or null hypothesis significance testing, we tend to discount any information outside of the data. And that sounds like a good thing, but it's actually not. Because if you think about both in research, but especially in industry, you often know something about your experiment, whether you've thought about it or not, before you collect any data. So for instance, in the case of industry, you might have someone who is a marketing genius and knows that no matter what you try, your click rate is probably going to be between 2 and 7%. You're not going to have a high conversion rate. It's just not seen in your industry. In a frequentist perspective, we would often not include that information in our analysis. You might acknowledge it, you might discuss it in a discussion section, but it's not actually a part of your computational analysis. In a Bayesian framework, you're allowed to input that type of information and quantify it. And I think that's what was so appealing to me, is I started to realize that people who were doing frequentist statistics still were making a lot of assumptions and had a lot of prior information they were incorporating. They just weren't explicitly modeling it as a part of their analysis. And so I really liked those two things: prior information that you can explicitly quantify and include, and also this idea that we don't have to have a decision-making procedure, although you can in a Bayesian framework, but you're not necessarily limited to that. You're allowed to have this continual updating or this degree of uncertainty that wasn't necessarily present with frequentist statistics. And so that's what made me fall in love with it. And then I discovered, past the Bayesian hypothesis testing that I mentioned that JASP and similar software do, into Bayesian parameter estimation, which is this idea basically that you don't necessarily have to always test one hypothesis against another. You can just make a posterior distribution that represents the information and beliefs that you have about a parameter value. So for instance, maybe I don't necessarily care if my parameter is significantly different from 0, but I do want to have a good guess at what the possible and plausible ranges are for that value, because I want to quantify if this experiment goes wrong, if this marketing campaign goes wrong, what is the probability that I'm going to lose money and how much money am I going to lose? And I think that Bayesian statistics really lends itself really nicely to that kind of question. So theoretically, that is why I like Bayesian statistics. And I think someone could probably say that a lot more knowledgeably and eloquently than me, but that's what drew me in. Practically, the software drew me in, because frequentist models seem to often be built as these discrete things, like a t-test is a t-test, a regression is a regression, a Poisson regression is a Poisson regression, and there's sometimes not a lot of flexibility that you have. You just kind of have to use something that someone else built, and maybe they'll think about a couple of tweaks that you could make to the parameters. Whereas Bayesian software like Stan, PyMC3, JAGS, bugs, whatever you're using, they're a little bit more difficult to learn, but they offer just infinite flexibility and also force you to think about the assumptions your model is making because you're often building it from scratch. So for instance, an example I can give you is that in my dissertation, I was running an experiment where for the same test, we had both a continuous bounded 0 to 1 response and a binary 0, 1 for various things that we were measuring. And both of these models were looking with similar predictors to predict whatever the outcome was. And so for one of them, I built a logistic regression, which probably everyone in the world is familiar with by this point. And the other one, I built a 0, 1 inflated beta regression. And the beauty of Bayesian models is that the way that I built mine in Stan, I got to see explicitly the connection between those two models. They're incredibly similar. Really, the only difference is that you're modeling one with a beta distribution, as the name suggests, and modeling the other where you're assuming that the actual observed events are zeros and ones. So instead of a beta, you have like a binomial. And when you code that by hand, you realize that. And so I think using Bayesian software, this is not a theoretical reason, but a practical reason, has really made me more aware of the flexibility and connection between models that I use and made me face all of the assumptions that I was making in my models without realizing it, because it no longer does everything for you.
This episode is brought to you by Z by HP, HP's high compute, workstation-grade line of products and solutions. As datasets get larger, unraveling meaningful insights can become more time-consuming and costly. Z is specifically made for high-performance data science solutions, and I personally use the ZBook Studio and the Z4 workstation. I really love that Z workstations can come standard with Linux, and they can be configured with the data science software stack. With the software stack, you can get right to the work of doing data science on day one without the overhead of completely reconfiguring your new machine. These powerful machines are being used to solve real-world problems as well. If you're a student and you want to get your hands on one of these, there's a great opportunity right this second. HP is hosting a Kaggle competition to identify and localize COVID-19 anomalies, and the student team that scores the highest will receive a top-of-the-line ZBook Studio. Now, back to our episode. Interesting. And so, just in summary, from what I understand, one of the things that differentiates Bayesian from Frequentist is the sort of like continuous nature of a model, correct? Whereas in Frequentist, like, let's say you want to keep things up to date, you'd have to retrain the model, continue to retrain, say on a like weekly cadence or something like that in industry. Whereas with at least some Bayesian models, that iteration loop is continuous. You're always assuming and evaluating new data. Is that like an okay assumption to make?
I mean, I think in Bayesian statistics, the way that it would be implemented in production, it wouldn't necessarily be the case that that has to happen. And I think that Bayesian statistics is less differentiated from like the typical ML models we put into production versus null hypothesis significance testing, which we use more in research, or even like A/B tests and stuff like that, because the things that I was talking about have more to do with inference than prediction. And when you're talking about ML in production, you're probably talking about predictive models. And so both of those could theoretically be updated all the time, or however often your computer or server can handle it, whether it's Bayesian or whether it's your typical like neural network or something like that. I think where it comes into play that the difference is the most stark is when you're doing inference about the models, because when we're asking hypothesis-driven questions, null hypothesis significance testing is built as a decision-making tool, and the Bayesian framework is a little bit more well-equipped to extend beyond that. Not to say you can't in a frequentist method, there are really great extensions and people who are frequentists who don't believe in null hypothesis significance testing. but Bayesian statistics lends itself a lot more. And I would say if you're distinguishing it from machine learning, the key difference would be the prior information that you can include. And you might say something like, oh, but don't we do that in Lasso or Ridge? And yes, you do. And I think it's a great gateway Bayes. So if you like regularization in your models, try Bayesian stuff because it's basically the same thing. In fact, Lasso is basically like putting a Laplacian prior that looks like that on your coefficients, and Ridge is basically like putting a normal distribution prior on your coefficients. So if you like that, try literally the entire Bayesian framework.
Very cool. I mean, that's something that I think is more and more valuable as we go down a more and more machine learning or data science driven world, especially when you're trying to explain why we should make certain decisions. I'm constantly running into issues with, well, like, we're not going to do this unless we understand how it works or what the implications are, whatever that might be. And there, you know, there's good things. I think a SHAP is one where we're able to understand certain things slightly better, but intuition and trying to understand what goes on essentially in a computer for business people is not always the greatest strength out there. It seems like magic. And
well, and they probably want a range of possibilities because business people are smart and they know that things are not going to go according to the point estimate that you've given them. And in frequentist statistics, you're often faced with, you know, a single number, a single effect size, something like that. And what I really like is that when you do Bayesian statistics, you have an entire distribution of information as your final conclusion, rather than something like just a point estimate or just a point estimate and a confidence interval. So to your point, I think business people really like that because you can not just say, oh, it's more likely that, you know, variant B of this email works better. You can tell them all of the range of possibilities and what the risk would potentially be according to the data and expertise that you have. And I think they love that kind of stuff.
yeah. And so, I mean, I think it's important to note the crossover between Bayesian methods and like more traditional simulation methods, right? I mean, I think that's something where you're getting almost not identical outcomes, but like the randomness is a huge component there, right? And you know, not all data science problems are best solved with like pure machine learning, right? I use a lot of simulation in my work, and I found that to be a very valuable tool. And it's like, you know, all of this is related to use the best tool for the question at hand, right?
Totally. And that's something that I have to remember because I think I went through stages of being taught only frequentist stats, learning about Bayesian stats. I actually joke. So when I was writing the Crash Course Statistics YouTube series, it was my first year of graduate school. And I was going through what I call my p-value angst phase. And I just was like, ugh, frequentist statistics. Like, who uses this? This is so pointless. And it kind of comes, you should watch some of the videos. It kind of comes across, unfortunately, in some of the videos. And I've come around, and I think both frameworks are incredibly useful. And I think I said earlier, it's a tool in your toolbox. You should know both. You should be able to use both and be able to correctly decide when to use each of them, because they really have their own strengths and weaknesses. Because if you are in a situation where you're running repeated experiments and you need to make a decision, that's literally what null hypothesis significance testing was built for. So like it maybe would be silly not to use it because that's its perfect use case. So I won't like disparage anyone who's using any method, but I reach for Bayes a lot more in the type of work that I do. And I've been seeing some really cool stuff with, even in things like neural networks or in XGBoost or whatever, people using Bayesian ideas, for instance, to do like grid search or to do things like that. And so I think it's something that can be your entire framework, or it can be just a part of your workflow, even if you don't like consider yourself a Bayesian.
I love that. Well, I would love to see you integrate some Bayesian thoughts and experiments in Sliced. I'm planning to compete in either season 2 or 3, and I'd love to compete against you. I think that would be pretty fun.
Okay, I've been thinking about that, but I'm pretty sure Slice is biased against Bayesians because of the 2-hour time limit. I will say, if you guys are considering going Bayesian, first of all, listen to people who are way more knowledgeable than me. I consider myself a practitioner of Bayesian statistics. I am certainly not an expert. But second of all, be prepared for very long run times because you are often using, as Ken was saying, like sampling, you're using Hamiltonian Monte Carlo or some type of sampling algorithm. It takes a really long time. So I have complained multiple times in chat on Sliced that I don't think I could compete because like the things that I'm most experienced with, I don't think could run in time. And the way that they do the metrics on Sliced, I think is also biased against Bayesian statistics because they're looking just at something like the root mean squared error. And I think the beauty of Bayesian statistics is your quantification of uncertainty, which is not something that you're necessarily measuring when you're giving a point prediction and comparing it to the truth. So yes, that would be very fun, but I don't know how Bayesian I would be if that were to happen.
We'll maybe dip your toe in some other methodology.
Yeah, I'll actually have to use all the methods that I teach every day in my data science courses.
Well, so that's another point. You said don't go to experts. You're a practitioner. You did just finish your PhD defense, correct? And you're now we can call you Dr. Parlett, correct?
Yeah, you can. And I'm the second in the line. My grandfather is also Dr. Parlett. So that was really fun because he was there at my defense and we're like, oh, it's, congratulations, Dr. Parlett. And I was like, oh, there's another Dr. Parlett in the room.
It's funny you should say that. So both my parents are doctors. Both my grandfathers on both my parents' sides are doctors. And I think my great grandfather on at least one of the sides was a doctor. Medical doctors, not philosophical doctors. But I don't know. I have half a mind to go back to school just to keep the line running, even though it would take significantly longer. But we'll see. If I ever get old and bored, I think it'll probably be worth it for me.
I won't lie. Half the reason I wanted to do it was just because I thought it would be cool to be called doctor. And spitefully sort of, I came from a community where like, men were always like treated as more important. And I wanted to be like Dr. and Mr. like when people address letters to me, which never happens anymore. In fact, I've had my PhD now for like a couple months. And today was the first time I took a random survey for some like company that sent me an email. And it was like, what was your highest degree and what's your like title? And I was like, it's doctor. But that's genuinely like the first time that it has mattered at all. So don't go to graduate school out of spite, I suppose, is the lesson there.
Well, I think that does raise an interesting question. You said, a lot of it is kind of a respect thing. And, I generally don't, I think people, if they want to get an advanced degree to break into data science, break in this field, if they can afford it, go by all means, but I don't think it's required. Do you think that there's like some like bifurcation or something like that around gender versus like level of education? Because, I think that it's like, wow, like frankly, women are very underrepresented in this field. And is it like, do you feel like, dang, I have to go one step further academically, I have to have one more social proof or something like that to be able to feel like I can, make as much of an impact as I would like to in this field?
That's an interesting question. I think that I have not felt that way. I had my own unhealthy reasons for getting a PhD, but I definitely don't think it's required. I do think that going the non-PhD route is a different experience, and it does kind of bother me when people will sort of devalue PhDs because they'll take the idea that you don't need a PhD, which is absolutely true, and take it one step too far to be like, it's almost bad if you get a PhD. And I always hate that. It makes me feel so bad about myself because I think it's just a different experience. Like, you have very different and very valuable experiences in a PhD, and spending those years getting industry experience or whatever it is that you do at that time. And I think you just get this deep and broad knowledge, because I would guess that almost no one in data science does in their day-to-day life what their dissertation was about, which is, half your PhD. But really what you learn is the ability to do this independent research in an academic setting. And so I think you get a little more breadth from the courses that you take, although you can get that through a master's or through self-study. But I think you get used to doing novel, independent research that is up to the level of like peer review quality, which is a completely different skill set than spending your time in industry and getting to know the expertise there, getting the domain knowledge, getting the like office politics if you're in a big company. And to tie all of this together, I would say I have not experienced the pressure of saying, you're a woman, you have to prove more that you are good at this. Or at least that wasn't something that motivated me to do a PhD. But I do think that there is a level of requirement of proof for women that they are experts in what they do. And this might motivate some people, but I would say my guess, which is a very uneducated guess, would be that that would not be a sufficient motivator to get a PhD. People are just experiencing the fallout from that in their daily life, regardless of what their level of education is. But I would say that non-men get berated sometimes for using their titles. And so I know there are a lot of people out there that will try and normalize, putting doctor in their Twitter name or title, or asking people to call them doctor in professional context, because there can sometimes be this idea that I can't even think of a good adjective, but that it's off-putting somehow when women demand that you call them doctor, or that you give them that respect for the title they earned. And sometimes men have a little bit more leeway in still having respect while having that attitude of like, you can call me John or whatever. So I won't opine about that too much because I don't think I have expertise, but my experience has been, I don't feel that that was a motivator for me. However, I do experience, and have seen other people experience to an even greater degree, what you were saying, that idea that there needs to be more proof that you're knowledgeable when you're a minority or you're not a man. And so maybe it edged someone closer, but I would hope that it didn't have such a significant impact to say, I wasn't going to get one, but I guess now I have to be a doctor. Because it's a lot. If any of you are thinking of getting a PhD, do it if you want to, but set up a really strong support network, both academics and non-academics, because it is a weird and rough time, and you can do it if you have the support system, but if you don't, it's probably not going to be your mentally healthiest years. So caution, but like, do it if you want,
I've heard quite a few people who have done their PhDs say something similar, where you're glad you did it, but you're like, whew, that was a bear. And I think that, going back to what it signifies, it really does signal that you can buckle down and focus on a very specific problem for a really long period of time, and
a
really
problem that you'll probably hate by the time you're done.
But I think that from now until forever, that's probably going to be a pretty strong signal for employers, is that, hey, this person has that ability to go deep and to really focus hard. And, in theory, like learning learning how to sit down and focus on one problem for a long time is a very important skill. Largely for this domain, sometimes you're working on a bunch of other stuff, which I don't necessarily think makes for effective allocation of data science resources. But, you know, I really liked how you put it around, you know, understanding exactly how a PhD fit into your life and how, you know, it seems like you're pretty introspective about it. I think that we both know that if you felt like it wasn't going to be worthwhile or you didn't want it, you would have been able to pivot because you've done that in the past. Or I went into political science, I didn't like that. You know, I went into this and I didn't like that. But it's all about, you know, are these things worth the cost to us in the short medium term for, you know, whether it's 50% a reason just because you wanted to be called doctor or not, but
which no one basically has. But I would say too that I recognize but don't like the idea that it's a signal to people, because it requires a lot of privilege to be in a place to get a PhD. You don't get paid that well, and you need a lot of connections and resources. And I always tell my students, because I do an AMA at the end of every semester, and I often get questions from students who are thinking about going to graduate school. And I tell them honestly that in my friends' experience and my students' experience, if you're applying for a large company job, degrees are a great way to get your foot in the door, because if you're getting hundreds of applications, an easy way to trim them down is, do they have a master's or a PhD? But I hate that. And I wish there were ways to more easily signal, or at least force companies to listen to that signal. Because yeah, it's a huge privilege to be able to make it through a PhD. And I fully believe you can gain the skills elsewhere if you try. And I think that's a difficult thing about being the type of person like doing SciComm that I do, is I always say that everyone is welcome, but everyone should be held to high standards, because there can sometimes be this idea, and this is especially true in statistics, like, you know, separate from data science, the field can be a little gatekeepy, where they're like, if you don't have 10 PhDs in, you know, all these really fancy areas, like you couldn't possibly understand this. And that's wrong, and that's horrible, and that's not healthy and not conducive to getting a diverse community. But it is also not healthy to say everyone's a data scientist. You don't even have to know or do anything, because that can sometimes breed, you know, sloppy work, people who have never been told that they need to be careful about this or that. And so my approach to it is to say, anyone can come in, but once you do, like, we're going to push you to be careful and rigorous and knowledgeable, because I think that you have to have a balance of that. You have to be able to say, we have standards, you have to be careful, you know, people's lives or people's money are on the line. But also, you don't need a PhD to do this. And so it's this weird balance of like, you need, I would say, if you want to be like super successful in senior level data science, you need like the equivalent experience of a PhD. You need to be able to prove that you're good on projects, working independently, working on novel things. It's just that you don't need the PhD. And I think sometimes people interpret that as like, you know, I can graduate from boot camp and immediately do this. And it's like, no, you need to get the commensurate experience. We just need to be more vocal about getting it through non-privilege based channels, so that people who can't get a PhD are still welcomed into those types of like roles, both in the community and in jobs, so that we can have, as I mentioned before, a very diverse and like well-rounded community.
Yeah, I mean, I agree 100%. I think that one of the things about a master's or a PhD is what you mentioned before. It's easy to quantify. And like the better, I think the more, essentially the more built out that GitHub gets, the more built out that Kaggle gets, the more built out that someone's individual blog gets, the more other things can start to signal and be reliable associated with those things. And I'm really looking forward to that. I think that that's like all of those things are very, what's it called? Democratic and pretty like well-maintained types of platforms. And I don't think that diminishes the value of a PhD. It's just, it validates that there are other ways to accumulate that experience and showcase that work and show that you've put in the time or the effort, or, maybe time or effort isn't necessarily the important thing, but it's that you can demonstrate the skills that you've accumulated. I hate to say it, but like there are people that could learn probably everything that I learned around data science in half the time, right? It doesn't mean that I should be awarded necessarily for my years, but for what I know and for my output there instead. I did want to shift gears a little bit. You brought up SciComm, and I'd love to learn more about that and have everyone listening learn a bit more about that as well.
Yes. Well, SciComm, or I guess specifically for me, StatComm, is a huge part of what I do. And probably anyone who's listening who knows me probably does not know me for my research, but knows me for my SciComm. I've always been really passionate about communication, and I generally just apply it to whatever I'm doing. In fact, to toot my own horn, one of my favorite comments I've ever gotten from someone was my stats teacher that convinced me to go into statistics wrote me a letter of recommendation and said, Chelsea's a 1 in 1,000 statistician, but she's a 1 in 10,000 communicator about statistics. And I think I really took that to heart because he said that very early in my career. And so I decided that I wanted to make things easier for people like me who were moving from an outside field into statistics and data science. And so I felt like I was good at communicating and started writing, mostly writing at the beginning, and then kind of realized that my snarky, weird sense of humor was something that could be valuable for communicating data science and statistics. So I started on Twitter. I don't even know why or what I did or how I got involved with the stats and data science community on Twitter, but I just started posting shitty memes about statistics. And I think that I learned along the way that that's a really good way to teach people things and to engage people, because as I learned more and moved from being like a little baby statistician to being someone who was seen as knowledgeable, people would always come to me and say, like, I felt so intimidated, or I don't think I can do this or figure this out. Like, I don't understand. And it made me really sad. So I wanted to create materials that were approachable, that made people feel welcomed, and that kind of empowered them to reach that level that I was talking about before, where like, you've got to be rigorous. And I wanted to encourage people and provide them with materials that could help them do that. So whether it's, bad stats memes that make people feel, disarmed and comfortable with statistics concepts, to, I've written a bunch of things. I feel like I've not written in a while, but the Crash Course Statistics series on YouTube was one of my earlier big projects. I've written a bunch of blogs for various companies explaining statistical concepts. And that honestly to me is more fulfilling than actually doing the statistics. Obviously, I still love doing the statistics. Sit me down and write some R code any day. But I really love empowering other people to do that for themselves. And I think that's been a gap that is sometimes missing. One thing that I started doing as a result of this SciComm, I had a meme go viral like maybe a year and a half ago. Viral for statistics tweets, not viral for real life. And I had been toying with the idea of doing consulting. And when that tweet went viral, I was like, oh my God, I've got to like capitalize on it. So I like threw up a website and put up this like casual consulting business. And I've not really poured too much time and effort into marketing it. But the idea was basically there are so many people out there, particularly researchers, but I do get some industry where they're doing their own methods, but they're not in-depth trained in statistics and data science, but they also don't have the resources to hire a statistician to do something for them. And so it tends to be those extremes. Either someone's struggling through it on their own, or they're resource rich enough to hire someone with expertise to do it for them. And there was this middle section where people were they sort of knew what they were doing, but they needed a little bit of help. And I really saw the consulting as an extension of that, where I was there to do casual consulting. I am not doing your analyses for you. I am not planning everything for you. I'm not writing code for you, but I'm helping you answer the questions that you don't know how to ask, or figuring out what an appropriate method is. And I see that as an extension of SciComm, because both SciComm and this are ways of empowering other people to learn and do things on their own. And so to circle back to the SciComm, I think that's what's important about it. It makes people engaged with the topic, and makes them feel like they're capable of doing it themselves. And so when something's intimidating, using TikToks, which is not a place that you would think to go for, science learning. Well, I do. Obviously, my entire FYP is science communicators. Can make it feel a little bit more approachable and doable for the average person who may feel excluded, even on other social media platforms. Like, I know Twitter can sometimes feel intimidating because there's a lot of really smart people arguing vehemently about things all the time. But seeing a joke or seeing a familiar meme format applied to something that you felt was complicated is a way to, if I can pull out my psychology degree, is a way to reduce the cognitive load on people. You're giving them a framework that's familiar or is comforting, and you're putting a difficult topic on top of it. And it really allows you to reduce the cognitive load, to have someone feel like they have the scaffolding to understand something that maybe previously they felt was like too difficult for them to personally learn.
I mean, I really love that. Obviously, that resonates quite a bit with all the stuff that I've done in the past, is that, I think we're in a very similar boat where I enjoy creating content. I enjoy helping people hopefully break into this field or maximize on their capabilities, or find a passion for this, or find out that it's even not for them, as much as I like doing the data science work to begin with. And in my mind, the more people that are in this domain or have an understanding of it, or whatever that might be, is a really good thing. It makes, in my mind, again, the world a better place, because people are more critically thinking about problems. They're more aggressively seeking solutions with data that's available, or they're producing more data, or whatever it is. And to me, that's a world that I would like to at least have some part in creating. And I think that maybe both of our parts is to be able to tell some of that story, or to pique some interest, or to, get that one chuckle, or to establish a little bit of that like subculture where it's like, oh, I get the jokes now, right? I know enough where, like, I thought this was funny and I researched it and now I get it. And I forget, there's like a learning model. It's based on motivation and aptitude. And, essentially, like, the higher your motivation, the less aptitude you need. But the more aptitude you have, you essentially need a little bit less motivation to be great, because it's already coming naturally easy to you. And playing with those levers, I think, is really fun and compelling. Is that, if I'm motivated by humor, or seeing what Dr. Parlett puts out next, I might be more inclined to, really continue and pick up learning and push myself harder than if this was just like a really boring task and I didn't have these other unclear motivators that are out there for me.
Yeah, I've had multiple comments, both on TikTok and Twitter. I think they're sort of joking, but saying like, my motivation to learn statistics is to finally understand the jokes and memes that you make, which I think is so funny, because I do make a wide range of like everything ranging from like p-values are bad kind of jokes to I've made a weirdly high number of very popular Hamiltonian Monte Carlo jokes, which is the sampling algorithm that the STAN language, which is a Bayesian language, uses. And you would think that like no one would care about that, but for some reason it's like quite popular content. And I think that's fun because that is something that's still intimidating to me. Like I've read the papers, I've tried to dive into the math, but it's like differential geometry, or I don't know, I probably just made that up. It's a very complicated type of math that like supports the sampling algorithm. It's like physics or something. And making jokes helps me feel like more comfortable with it. And so I hope other people feel that way. And I like definitely think with the number of people that like and engage with the content I make about Hamiltonian Monte Carlo, it's probably a lot of people like me who like have heard that name, but don't truly understand it yet. And I hope it makes them feel like maybe like it's a little more approachable for them.
Yeah, well, I think the power of memes is that the idea is that they are relatable, right? And it's that I'm not the only one that's struggling with this, or like we all have this problem, right? It's, you know, like, oh, I can't think of a generic problem right now, but I think we get the idea.
When your R hat is greater than 1, which
exactly.
is a metric you use to see, yeah, if you're fit. Anyway, maybe it's better if I don't explain the joke.
Exactly. No, I really like that. And obviously something that comes out of that, or comes out of all of SciComm, is making this transition into this field from essentially any domain, right? And we talked briefly offline about like research liaison positions and how that has made your transition into this field possible. And I'd love to hear more about that, or more about some ways that you find that increases the accessibility of this field to people who are not coming from just hardcore computer science, statistics, whatever the domain it might be.
Physics. There's a lot of physicists in data science.
A lot of physicists.
Yes. So I think what we were talking about a little bit is that you need connectors, that people who can kind of get a little bit of the domain but have a lot of computational experience. Because I think what statisticians, especially data science as well, what people can forget is that your expertise is not better than the domain experts. And sometimes I think people come in with this attitude of like, oh, I'm going to help you with your data science. And, you know, look at me, so smart and knowledgeable. But what we need to remember is that our knowledge is not more important than the domain experts. In fact, their knowledge is probably more important than our knowledge. And you need people who can get those groups to effectively communicate. And so sometimes that can look like a domain expert who has a lot of technical knowledge, who's able to connect what the domain experts want with what technologically is needed in that situation. I have a friend who works at a big company that does that, and they focus more on the human side, like their expertise is more in psychology, but they have the technical chops to be able to communicate with, very siloed statisticians and data scientists. And then there's people like me who I have found it to be incredibly beneficial to my career to have that psychology background. My entire dissertation is basically reads like a psychology study. I just have like very fancy methods. And it's been really cool to connect the people that I used to work with, or still do work with and collaborate with in psychology, with methods that just improve their inference a lot. And because I worked in that field, because I collaborated with those people, have heard what they're interested in, what they're doing, I'm able to kind of like pluck methods from my broad expertise that I've developed through the PhD and go, hey, like, remember that problem we were having? Here's something you can do to try and fix that. Or here's something that you can do to get around it. And if I didn't know how to communicate with them, what the pros and cons of that were, or if I didn't know enough about what they were doing to know that they had that problem, the solution probably wouldn't find itself. And so I think people that can connect domains, whether for me that's psychology, whether for someone else that's marketing or biology, whatever, it's really important to have people that are connecting those fields because they do not communicate well. Like half the memes I make on Twitter are just about how confusing statistics jargon is. And I think that can be off-putting. And actually, someone posted a paper recently that I think is a really good analogy for this. I forget what the field is. I feel like it was medicine. They published a paper that was basically like trying to reinvent the trapezoid rule for integration. And this went through peer review and was published, and it's just the trapezoid. I mean, anyone who's taken calculus is familiar with that. And it just struck me as really funny because if they had, like you were saying, like a research liaison where they could, communicate about technical methods that already exist, like that paper wouldn't be necessary because they're reinventing the wheel essentially. And I think that can happen a lot. And I've seen that happen where people will be really smart and think of new methods and then realize like, oh, actually there's been people thinking about this for like decades and they're not like benefiting from all that thought and resources that already exist in a different field because we're not connecting people. And I would hopefully like to connect people more, whether that's getting domain experts to be more expert or getting statisticians and data scientists to be more amenable to communicating with those domain experts. I think that's super important, not just so that we're not reinventing the wheel, but also so that people can feel valued for their expertise no matter which side of the aisle that's on.
I really like that. And that's something I feel pretty strongly about as well. So the course that I co-taught this year was called Designing Ethical AI Systems. And essentially the majority of the class were designers, not data scientists. Mm-hmm. And essentially our class was hopefully training them to work with data scientists in the future, because as you might expect, data science and design go pretty aggressively hand in hand. And the idea that designers can learn a little bit more about data scientists and data science should definitely learn a little bit more about design is something that I think is overlooked. I mean, we look at specialization and siloing, and I think that there is some value in specialization, but you should be specializing in probably the problem you're solving using a multi-dimensional problem-solving approach. And so it's like, rather than siloing down in data science, like let's think about the problem we're solving more holistically and figure out what elements or what different types of things are associated with that. And facilitating those communications is something that I think is relatively difficult for organizations. I mean, it's relatively difficult to even do in a class. And I'm excited that you're working on making that more accessible to people.
Totally. I am too. I think it's very important. And I think I often emphasize it in my class that I teach to undergraduates that, we go over technical stuff, we're coding and doing math, but I spend a lot more time than I think most people do on empathy, communication, and domain expertise, because I want my students to come out and value that. Whereas I think that a lot of times there's an attitude that those things don't matter, or that you should develop those things for some reason on your own. And it can sometimes lead to like a lack of empathy or that gatekeeping, or sort of snobby is not the right word, but this idea that your knowledge, as I said before, is more important than the domain experts. And so I try and drill that out of my students as much as possible, because I want them to be good collaborators. And most of them will not go into data science, so they can use the skills elsewhere as well. And I think that's important. So I hope if anyone's listening to this and you're creating educational materials or you're teaching, that you spend more time on empathy and communication, because sometimes I see that as lacking, not necessarily in the people, but in the curriculum that we generally use to teach data science. And I wish that were a more official part, instead of having people to try, like having students need to piece that together on their own outside the classroom.
Awesome. Seconded. Is there, that's honestly all the questions that I had. Is there any final thoughts that you perhaps have? I'll also make sure I link your Twitter, your TikTok, any of the content, the video content that we referenced in the description below. But do you have any perhaps final words of advice, causes that you'd like to bring awareness to, whatever that might be?
That's a wonderful question. I wish I prepared something more official, but I don't think I have any advice that we haven't covered. So I will just reiterate. I think that it is so important to both encourage open-mindedness and empathy in data science, both communication and in practice. We spend a lot of times, well, you're familiar, on ethics in my class, because sometimes we focus too much on the technical aspect and not enough on the human impact of the models that we're building, whether that is the environmental impact of training natural language processing models to the actual predictive impacts of our models. And I think it's really important to do that and encourage that and pursue that, even if your teachers didn't encourage you to, but also to be technically rigorous. And I think there are so many great people out there writing the most rigorous, the most technical things out there that are so incredibly helpful. But we need more people to connect the dots, because when you come in to the field, it's really intimidating. And I have been made to feel less than by so many people, more at the beginning of my career than now, but like that they're like, oh, you're not good enough. You're never going to be able to do this. You're never going to be able to understand this. And so I hope there's people out there that are watching this that are saying like, oh, I want to be a connector, to connect, beginners with this more technical material. So to summarize, I would say, I hope you hold those things not in opposition, but both with like very heavy weight, that you need to be open, you need to value other people's expertise, you need to be empathetic and good at communicating, but you also need to be technically rigorous. And I hate when people put those as like diametrically opposed things, because I think you need both to be a successful data scientist. And so since there's so much technical stuff out there, I think I've spent a lot of my career focusing on the open empathy and communication. But I hope people know that both are incredibly important. And that's what I'll leave you with.
I don't think I could agree more. It was maybe in terms of the ethics front, I think it was Jurassic Park, where they said we spent so much time thinking about if we could, we didn't think about if we should. And yes, they probably cut some corners with their research and their rigor and that stuff as well.
Maybe. So IRB was not involved there.
Exactly. Well, Chelsea, Dr. Parlett, thank you so much. I really enjoyed this, and I think everyone's going to take quite a bit out of this one.
Well, thank you for having me and letting me rant about all the things that I mentioned. I'll make sure to provide you with resources, because like I said, I'm not the expert here. There's so many great resources to learn things like Bayesian statistics. And I hope people check those out, because I hope to be the one to point you to those resources. Maybe I'll create some, but I think there's a lot smarter people out there.